All right. Hello, everyone. I did want to say good morning. It's not good morning. Good afternoon. It's 3 o'clock. Hi, everyone. How's it going? I hope you've been going well. I've been trying to answer these questions, but they're coming very, very fast. If I didn't answer some of them, I've got the usual Tom is now in the chat. So he's going to endeavor to answer some of them. And then if we miss any of the questions, feel free to ask them again or pop it in the forum, in the chat. Oh my gosh, I can't get words out today, which is not that good for the lecture, but I will be able to get them out in about 5 minutes. All right. Okay, I think that's all okay. Why am I not typing as fast as I did on Tuesday? During the lecture, it was Tom typing on Tuesday, the other Tom. That's why. And then, yeah, and I've got nails. I don't type as fast. There you go. But still very fast, but it makes a very pleasant sound when it hits the keyboard. All right. Well, welcome to week 3, the last lecture of week 3. How exciting. Probably your last lecture of the week. I don't think there's any more lectures past this time. This is not a good time for a lecture, but this is a great time for a coding lecture, I guess. So there we have it, Friday. All right, I'm going to be running a Slido again to keep the pace of the lecture at a level that everyone understands, because as I understand, people had trouble with the function stuff. So I'm just going to go to the Slido. Who knows where it is? Tom is going to keep me updated. Okay, no, he's not. He's not. He doesn't have the link. I'm just, hang on. Here we go. Okay, it's running. I've got it open so I can see. Okay, so yep, he's given us the link and the code as well. So let me know how you're going. From last time, from what I understand is people would like a recap of the functions. So we're going to do a recap of the functions today. And then we are going to do arrays, which is super exciting. So we're going to start to look at some one-dimensional arrays, what they are, why we use them, some examples, and so that we can start building towards week 4, when we're going to look a lot more at arrays, and because your assignment 1 is going to be all about arrays, just in case you were wondering and you want to be super excited about it. Okay, Tom, could you please pop into the lecture chat also the link for where the code is today? It is in the same place that it was on Tuesday, but Tom will pop the link in the chat as well. So let's do a little recap of functions, okay? How's everyone right now feeling about functions? Actually, let's do a quick poll. How are you feeling about the functions? The functions. How are you feeling about any functions? There's no poll running. Do you want me to run a poll? I can. Here we go. How do you feel about functions? I can't spell. All right, there we go. Okay, it's running. Oh, hip hip hooray. That's a great little pun. Love that one. Not fantastic, but all right. Yeah, okay. Definitely need a recap. Bit iffy. Okay, that seems very reasonable for something that you've only heard about once. So do not worry. We're going to talk more about functions. And then from now on, what I will do is I will also break up my code into functions almost every time so that you get to see it in practice as well. And so that you get to do a bit of practice as we go as well. So let's do a little recap. Functions. A function is a block of statements that performs a specific task. So all it is me cutting out my code, cutting code out to move out functions into their own separate little beings, and giving them a little bit of independence. So really trying to improve, why do we use functions? First of all, it's to improve the readability of the code. So if you imagine 1,000 lines of code all sitting inside your main, you're going to have a little bit of trouble reading what on earth is going on in that code. So we want to improve the readability of the code. much easier to do with the use of functions, because the name of the function should also be descriptive to what that function does. So if you're saying what the function name is, giving it some inputs, it's straight away more obvious what it is that you're doing. It improves the reusability of the code, and that's because once you write a function, you can reuse it. So what that means is that you can use that piece of code somewhere else as well as needed. So, you know, if you've written a function, I don't know, to print out an array, then you can use it again and again and again in different pieces of code as well. It does make debugging easier. And that's because, again, you don't have 1,000 lines of code that are all leaning on each other. The reason it makes debugging easier is because you can switch functions on or off by commenting them out. So you can kind of try to single down which function is it that's causing you pain. So you can, it's much easier to narrow down where your issue is coming from. So definitely, you know, hopefully it will improve that in the coming weeks as well. And it also reduces the size of your code. And the reason for that is because you're not, you're reusing functions as well wherever they're needed, but it means that you're not repeating your code every single time. So every time you need to print, you know, I'm just going to print an array. We'll talk about arrays in a second, but every time you need to print an array, you're not kind of just writing that piece of code over and over again. You just call the function to do that. So it's, you know, one line as opposed to doing 5 lines of code each time. So there's good use for functions. Part of it is that it makes things a lot easier to read. So it improves how a human can read it. Part of it is also that it makes debugging a lot easier. So it's a very good practice to get into. And that's why we start doing functions so early on as well, so that you don't form any bad habits of writing, you know, 1,000 line mains yet. Okay, so so far we've used predefined standard library functions. That means they're like built-in functions almost. Things like printf, scanf that are sitting inside stdio.h. So they are predefined functions that we can just use as we want. What that means is we're basically borrowing them. They're already written. We don't have to write them. We're borrowing this function and we're using it because we can. And now when we are doing our functions, those are user-defined functions. So we become in charge of the function, and it's up to us what it is that we feel in our code can be separated out and made into its own block of code or into its own set of instructions that can be executed when we call out to this function. So the syntax for a user-defined function is to do a return type first. So you have to say what is it that you're returning. Then you say the function name, which you're in charge of. So you give a descriptive name. That's part of good style. And then in brackets, you give us, give your function what arguments it will be given. So what inputs are going to go into this function. And you do that in the syntax in the format type and then the name of the argument. Okay, and then curly bracket and close bracket. Then you've got your block of code, which is a set of instructions for the function. And Tom's just written a question on the board, so I'm just going to quickly answer it. The question is, can you use functions in assignment 0? We did learn functions in week 3. If you would like to, you can use them. You do not have to use them, okay? You will not be marked better or marked worse for using them or not using them. So we're not looking at you using functions at this point of the game. In assignment 1, you will have to use functions to gain style marks and to just generally make your code a lot easier to understand. So in this assignment, you don't have to use functions if you don't want to. You know, don't feel pressured to use functions. They're great, but you can still put everything in your main for now. Okay, so if I'm going to do a recap, I'm going to do a recap. Let me do it in code so you can see it used in code as well. Where's my tiger? Here it is. My beautiful tiger. Let me open this up a bit more. And let me clear this. Oh, what a mess. Let me make this much cleaner. Sorry. Is this fast enough typing? Ah, oh, why would I put a dot? There we go. Okay, let's have a look what we can do here. All right, So what I'm going to do is I'm going to actually play around with this recap. Oh, actually, someone's just asked a question on the chat. That's very good. Would nested if statements be marked down? Okay, this is a great example also of something that is much easier to fix with functions, okay? If you have this crazy nesting going on, usually the only way, well, one of the only ways to fix it nicely and neatly is to use functions. So in assignment 0, you're not really going to be penalized for nesting so much, but in assignment 1, you will be, because you now have access to functions, so you're able to cope with the nesting. So you can still nest. Not for long, not for long. Okay, so let's have a look. Okay, so let's do a recap of functions. I've got a simple piece of code here. Okay, right now it's a int main, and it takes two numbers, number 1 and number 2. So two variables, two ints. I ask the user to enter in the first number and store it inside number 1 variable. I ask the user for a second number and I store it inside the second number 2 variable. What I do then is I take the result, I add up the two numbers, and then I print out the sum is, and whatever the sum is, that's what the answer is. Return 0. So let's say I want to take out the addition part of it, and I want to take it out outside of the main. So the way that we work usually, as you kind of go through the course and then as you go on to, other courses as well, what we try and do is we really try to do anything that's like functional in a function. So all that we want to do in a main is make calls out to things, really. And that sometimes helps to break it down even further, but then you go too hard. So you have to be careful of that as well. It's not like every single thing has to be moved to a function. But let's move the addition of things into a function. So let's say I want to move an addition into the function. So I will create that function. Okay, let's create a function to add two numbers together. Okay. Now, when you are creating your function, okay, you need to know what the inputs are, what the output is, and what the name of the function is. So let's do that, okay? So what's going to be the input to our function? If I'm adding two numbers together, what will be the input? Okay, yeah, two ints. I like that. So we need two integers. We're adding two numbers together. What's going to be our output? Yep. Yep. And what are we going to be outputting? Yeah, one int. That's right. So I'm going to be output is going to be, one int. Excellent. And what am I going to call my function? Oh, well, I can call it sum, I can call it addition, I can call it something that is descriptive to what it's doing. So whatever you like, right? It's not, I'm just going to call it sum or addition is good as well. I'm only going to call it sum because sum has 3 letters in it, and that means I can type less things. Okay, so the first thing we put down is sum it up, that's a good one too. Okay, so we're going to put down a return type. So my output is going to be an int, so my return type is an int. Then the name of the function, which is going to be sum. And then inside brackets, I'm going to put down my two ints, which is my inputs. So I'm going to put down the two inputs. Okay, so again, someone's asked, why do we need a function for this? Can't we just do a plus b? You really can, okay? Absolutely. I'm doing it in this case in particular because this is a really simple way to show what a function is. So I'm not taking out, and usually a function is not going to be 100 lines of code. Functions are short blocks of code that perform a certain function. So you are separating it out so you can just make calls from your main and have much neater code. And that means that you can call your sum each time you need to add up two things. So I'm trying to do a simple example of how to take something out to a function and then play around with it a little bit. Okay, so two ints. I'm going to have int number 1 and int number 2. Okay, and then open curly bracket and close curly bracket. Now I'm returning an int. So over here is going to be some sort of integer. Okay. So I'm going to have to return an integer. So there's going to be an integer there. Alrighty. So the whole point of my function is to add two numbers together. And I want those numbers to be number 1 and number 2 here. So let's say I have an int result, and I'm going to say that it's going to be equal to number 1 and number 2. Okay. And then that means what I'm returning is I'm returning whatever the result was, which is just my result. So now I've got number 1 and number 2 because those are the numbers that I gave my function. So whatever's stored inside number 1 and number 2 is what I gave it as inputs. So I'm going to give it number 1 and number 2. I can also just do, I can simply do return and then I can say number 1 plus number 2. That's fine as well, and I don't need to write anything else. So that's a shorthand way of doing it. I can do this because this thing here is going to be an integer as well. So I will still be returning an integer even if I do that. So that will work as well, absolutely. Someone said, is it okay to name them num1 and num2? You can name them num1 and num2. That's okay. That's still descriptive enough. Okay, so now we've got a function that adds two things together. Okay, so instead of having this line here, which I'm now performing, what I'm going to do is I'm going to call my function out. Okay, so, yeah, I've noticed. Yep, here we go. Yep, sorry, apologies. Maybe that's the nails fault as well. They're not even that long. Anyway, okay, so I'm going to call out the function. So the function is called sum, and I call a function by its name. So exactly the same way as I would call a person by their name. So I'm going to call sum. I'm going to say, hey, sum, I want you to do something for me. I want you to add two numbers, which is your whole purpose. So please do that for me. But I suppose I need to give you two things to travel down with. What are the two things that I want to add? So what are the two things that I'm giving you as input? Now I've placed my numbers into these variables here. So that's what I'm going to give my sum. Okay, so I'm going to give it number 1 and I'm going to give it number 2. So you do not need to specify the type when you're giving the inputs, as long as those inputs match the types that are given in that function. Okay, so we've got our sum, number 1, number 2, and then we're going to print out, what are we going to print out? Right now we're printing out nothing because the result of this is not going anywhere. So I'm going to say that int result is equal to sum number 1, number 2. So I'm making a call out to a function and I'm storing the result of that inside the result variable. Okay, and that's going to go in here. Now someone has said, did I make a prototype? I did not yet. That's going to be the next thing I do. Very good. Okay, so the way C is reading this piece of code is line by line. Okay, so it's starting from int main void. It's going in and it's reading. Now when it gets to this line 19, when I'm calling out to my function, if I do not tell it that this function is coming, okay, what's going to happen is that it's going to throw me a compiler error because it's going to say, hey, you're calling a function that doesn't exist. So one way to solve it is to place the function above the main instead of below the main. However, this is not a good solution, okay? Even though then C will be able to see that this function exists, it's not a good solution because usually you have more than one function, okay? And that means that your int main might get lost 1,000 lines down. Now, since the computer starts reading at the main, what happens is that when a human needs to see what's going on and they need to start reading at the main, they're going to go down to line 1000 and they're going to, you're going to go crazy because you're going to try and find it. So the way we cope with that is we do called a function prototype. So we're going to tell it that something is coming. It's going to be called sum. It's going to be really good. It's going to solve all your problems. Don't worry. We know what you want. We know that there is something. So we're going to call it in here and we're going to say it's coming. It's coming. Don't worry. And when we do the prototype, we've got a semicolon to finish that expression. And you basically, your prototype is the top line of your function declaration. So you're doing a function declaration. That's your prototype. This is exactly what this function looks like. This is what I'm giving it. Okay, so that's how you do the function. So someone has, Jack's asked a great thing here, and oh, I can see Tom's written it on the board as well. Okay, I don't have to have this as number 1 and number 2. I can have this as num1 and num2, and it will still work, except I have to have num1 and num2 here because that's the 2 numbers that I've given it. And that's because when you're calling a function, what you're doing is you've got 2 things that you're calling the function with, number 1 and number 2. Whatever is inside these 2 variables is going to get copied into these 2 variables. Okay, so it doesn't sound very efficient, and it's not particularly efficient, and we will learn a way to overcome this inefficiency in 2 weeks' time. So don't worry, it's happening. But what it means is that we, in fact, you don't need to have the same variable names as long as it matches up the prototype up here as well. So you'd need to change this one as well to be matchy. Okay, so let's save this and let's try running it, and then we're going to do something else. Okay, so DCC, I've forgotten what I've called it every time. Function recap, yes. Okay, function recap, yes it is. Okay, running, it compiled, excellent. Okay, then I'm going to misspell here we go. Function, enter the first number 3, enter the second number 4, and the sum is 7. Amazing, it can do maths. How good is that? Okay, so the other thing that's going to happen, someone's function argument order. It matters. You have to do them in the order, okay? Because you're telling them which numbers. I mean, in this case, for this particular function, you're adding 2 numbers. I mean, it wouldn't really matter but just keep it in the same order, okay? Because that makes it more intuitive as well. Often you're going to have types that don't match up either. So remember, whatever is sitting in here is going to get copied to this one. Whatever's sitting in here is going to get copied to this one. So that's why just good practice to put them in the same order as well. Okay, so let's say I'm thinking, well, this is getting a bit ridiculous. You know, do I need to print this outside, or could I print it inside my function as well? Okay. So what happens then is that I can actually move this print statement inside my int sum. Okay, so let's do that. I'm going to cut that out of there, and then I'm going to move that in here. Okay, I'm going to move it in here. Fantastic. Okay, what does that mean? Do I need to return anything here? I don't need to return anything, do I? If I'm already printing out the answer. I don't need to, because the return comes to the same place where you called the function from. So that means I don't need to return anything now if I'm already printing out the results, okay? And what that means, if I'm not returning anything, I'm no longer returning an int. What I'm actually returning is a whole bunch of nothing, which means I'm voiding the return. I'm saying I'm going to void. There's nothing that's going to return, because I'm just going to print out the sum right here. That means I don't need this here. I can just make a call to my function and it will print out the value just there. So let's try that quickly. Let's compile it. Okay, so what does this error mean? This error means that I changed my function to a void over here, but my prototype is still telling that it's going to return an int. So it's quite rude what I'm doing. I'm telling it one thing, promising another thing, not going to keep my promises because now it's void. So let's try that. Okay, save that. Let's compile it again and let's run it again. I think someone's asked why it's called something different. I can call it whatever I want. Okay, and I always I'm a little bit lazy. So this is why it's just called function here. So the file name has to be exactly the file name. It can't change. But after the O flag in DCC, I can call that function or whatever. I can call my piece of code whatever I want. I think you've seen me write Tom's seen my screen and it's just test. I just call everything test usually. So apologies. I'm that person that has 1 million things on their desktop. It's not pretty. It's not pretty. Okay, so now I'm going to do 3, 4, and voila. Sum is 7. It's done it by using a function. My goodness, the lack of new line is really annoying me, so I'm just going to put that in there. So that is functions. How are we all feeling about functions? Could you please take a little vote in the Slido to let me know how is everyone feeling? What if you want to return 2 values? Oh my goodness. That's not really something that you can do. But we're going to, this is a really good question, okay, super good question, because often we will have a case where I'm like, it's a bit rude, I really do want to return more things, and we're going to be learning how to go do that in week 5, and you're not really going to like me very much when we start learning about that, so I'm just going to hold on to this for a little bit longer. You're not going to like me at all. Okay, what's the difference between int and void? Okay, int is when I'm returning an integer, and void is when I'm returning nothing. Okay. So, yep. Okay, any other questions about functions before we move on? Some really great questions. Great question. Yes, okay. I think Tom's written use structs in function arguments. We can, because struct is just another variable. And this is one of the reasons, okay, if you remember I said to you when you're defining your struct, you'll do so outside the main. And the reason we do that is so that our struct is available all over, okay? So today I'm not going to do any structs, but on Tuesday next week I will do a struct. And so you can absolutely use a struct in the function, and that's why we define our struct outside of the main, so it's available to every other function that we potentially have in our code. And we will be doing a struct on Tuesday next week. Can you put a printf outside of the int main? No, it's not going to compile. It has to be inside a function. Do we only remove return and use void when we're printing in the function? Yeah, so you do it when you're not returning anything from the function, and when you're printing in the function you're not returning anything, which is why you don't need to have the keyword return. Yeah. Okay. That's really good questions. Really good questions. So yeah, so remember struct is just another variable type, so you can use it exactly the same as any other variable. Can a function be inside a function? Oh God, I feel like we're in the Matrix. No, it can't be. You can call other functions from functions, but you can't have like a function inside a function. But you can call any number of functions from a function. Oh gosh. Oh, good. We're making function puns. Okay. It's what puts the fun in function. I love it. They get more fun the more you use them. They do, right? They become second nature, right? You get to the point where you are basically, you know, the slightest thing when you're like going, can't you just add up the 2 numbers? This is crazy. Why are you creating a function? My headspace is now that, oh, look, I've got a plus. There's 2 things. There's like 3 things written down. I can move that to a function. So you're going to really, you're going to get to the place where you're going to be like everything can be a function basically. Can you show us how to call a printing function within the sum function? Not sure what you mean by that. But I will. When I do the array demo, I'm going to call a function inside a function. I understand what I think I understand what you're saying. You want me to call a function. Yeah, you want me to make a function, call in a function. I only have one function. That's the problem. I can't. If I had to, look, let me make another function. Why not? You know what? I'm going to go crazy. I'm going to just make a printing function. So I'm going to have a void print function. Okay. And I'm not giving it anything. So there's going to be no inputs to this function. I'm going to give it the result. Okay, So what I'm going to do is I'm going to take this statement into a function. Okay, now this is going crazy. Okay, this is breaking it down to a point that it doesn't need to. Don't do this at home. Okay, but just to show you that I can keep breaking things down if I want to. So what I'm going to do is I'm literally going to take this, cut it, and move it into this function to show you that I can make a function call from inside another function as well. So it's just going to be printing out sum is, and then it's going to print out whatever is given to it in this result. And that means that this function is going to have to return an int, because I'm going to have to give something the result. No, I don't. But no, I don't. Anyway. Yeah. Okay, so here inside here, I'm going to call my print function. So I've got print, and I'm going to give it an input. I'm going to give it result. Okay, so let's break this down even further. I'm going to compile it. Okay, I forgot to do a function prototype for my new function. Let me do that. And paste this. Okay, save it and run it. And what have I done now? Oh, okay, because I changed the type. Okay, I've changed this type, but I forgot to change the prototype. This is going to be a lot of your errors now, is going to be your prototypes not matching your functions. Okay, call it now. I'm going to enter first number, second number, and then it's still printing out the sum. Okay, so what I've done is I've called another function inside this function, and so on and so forth. So you can make calls from anywhere, right? Functions can also have no input. That's right. They don't have to have an input. And the one that has no input that you use all the time is your int main void. You have no input into this function, which is why it's void in here. But don't worry, we're going to learn how to input into a main function as well in the coming weeks. So lots of exciting things coming, okay? All right, I hope that answered it. You can return an int and a printf. I really don't need to. I really don't have to return anything from this function. You know, I'm not sure why I did. But anyway, now that I did, I can just return 0 there if I want to. It doesn't matter, as long as it's an int, or I can void it again. Why can't you go void main void? Okay, excellent question. And the reason for that is usually we want to know what happens in our main, as in, did we successfully finish running our main, or did our main finish running with issues? So that's why we usually return 0 to say that the main has finished running and it has finished running successfully. Yeah, so Mark, in this case, we actually took something and made it worse because we made it longer. Exactly. So don't break down one lines into a function. You don't need to do that. It was just to demonstrate what you could do. What's the difference versus int main void main void? Okay, what I was saying, so usually you have an int main void because you want to return something, a 0 or a 1, to show what's happened. Yeah. Sometimes you're returning an int for your own, for like debugging purposes, or for actually just saying, have we been able to successfully run through this function? Can int main void be without a void? It can be. You can just leave this blank, but it's not very good style to do so. You can do that and it still does the same thing. Okay, but it's good style to get in the habit of writing void so that you know what's going on with the void. Okay, like, can we return, let's say 10, and then we return a statement, let's say hello, from the same function? Well, you say if you're printfing, that's not a return. Printfing is just printing something out to terminal. You can only really return one thing. With while statements, do we have to define the variables, right? I'm not sure what that's asking. I'm not sure. Maybe clarify that, please. There are things that you can do. We're coming to doing the arguments into the main. Don't worry. The second one calls for a return of the first function, although it has not finished running. So the way they run, oh my God, am I about to draw you something, how it runs? I think so. I don't know. Is this too much? Maybe too much, and I should do arrays. Yeah, it's too much. Okay. I will draw for you a calling card. Maybe, I think next week I've got a diagram that draws the calling card. Okay, I promise you. The way it runs, because I don't want to overwhelm you by how it runs. So just for today, trust me, that when it makes a call out to a function, what happens is it goes to that function, and then whatever happens in this function, it returns back to the point from where it was called. Okay, so just go with that for now, and more will be revealed. It's a whole theater of memory here. Okay, let's do and I've made a lot of notes just in case you are interested again about the functions in the lecture notes. I got a little bit excited. Okay, someone's asked, can you call main from another function? No, you cannot, because you always are in main, and when you run a function, you return to the main. So it's, you always return back to wherever you called from. Okay, so you never just go off and like, all right, well, don't worry about it, I don't care about you anymore. You always return back to the line where you were calling from, and so it returns back to the place where it was called from once it finishes running. Okay, I'm going to do a little bit... Oh, should I do a little bit of memory? No, I'm going to skip this. I'm going to do more of this memory stuff. I'm just going to talk about arrays, and then we're going to talk about how it's stored. I don't know if you've noticed, I'm obsessed with memory, okay? So I always try to explain things, how they work in memory. I will explain it to you on Tuesday, okay? For now, I will say that we need memory to make things happen, okay, which is maybe why I'm obsessed with it. And when you move on from, in 1511, we don't really care if you waste memory, okay? It hurts me to say that, but we really don't care. So this is your chance to learn and to practice things. It's like a sandbox, right? You can do whatever you like. We don't care if you waste memory. But when you get into the further courses, the more memory you waste, the slower everything becomes. And what that means is, you know, your programs become less and less efficient. So it's something that you will start to learn how to avoid. But for now, we want you to focus on just practicing the actual theory that we're teaching you. Don't worry about the memory. Okay, so we learned two data structures in 1511. Okay, one is arrays, and we're about to learn about arrays. They're pretty exciting, and that's going to be your assignment 1, all about arrays. Pretty cool assignment. I'm not going to be biased here, but I'm completely biased. And then we're going to have a linked lists assignment, and also that's our second data structure. We're going to start that after flexibility week. I love linked lists. It's where you're really going to see my just, absolutely amazing drawing skills, and it's going to be another really cool assignment. So again, not biased at all. Okay, there are other data structures, okay? Those are not the only two data structures that exist in computing. There are other data structures that you will learn about in further computing courses. These are the two that we learn here. They're probably two of the more basic ones, but they're really, really important data structures. You really need to understand them to be able to go on further in computing as well. And so as you're learning this, we are going to learn the syntax to use these data structures in C. But I want you to remember that the data structures themselves exist in every other language as well, really. So you need to be able to understand how an array works, on its own. But then in this course, you will also be programming with it, so you'll learn how it works, the syntax for it in C as well. Now, choosing the right data structure is part of the reason we learn about quite a few data structures, because that's what makes your program sort of sometimes more efficient. So there's problems that require you to use arrays to be more efficient, but there are also problems that require linked lists to solve. So you'd be able to solve it with an array, but it's going to take you 7 weeks longer kind of thing, and 1,000 lines of code as well. So some structures lend themselves much better to certain types of problems, and we're going to talk about which ones are going to be going on. So I said I always hear jokes about reversing linked lists, but I have no idea what it means. Are we going to do anything like that? We are indeed, and I love reversing a linked list because that is the height of diagrams. You really have to really draw it out, and I really want you to get used to drawing a diagram to help you solve a problem. Okay, so without further ado, the array. Who has heard about the array? Who has ever used an array or heard about an array? Pop it in the chat if you and array are personally acquainted. Yes, Tom, that's right. You will be a pro at reversing a linked list. Yay! A few people have heard about the arrays. A few people have not. Excellent. Why the hype on diagrams? Oh, because diagrams are one of the ways that we can problem solve. Okay, excellent. Bit of a mixture. Excellent, excellent. Yep, amazing. Okay, all right. Okay, so a few of you have heard of arrays. A few of you haven't. Don't worry, you don't need to. I just wanted to see what the vibe is. Who knows what arrays are? Okay, so arrays are a collection of variables that are all of the same type. Okay, so how is this different to a struct that we've learnt so far? Struct was a variable and it could hold a collection of things. Oh my god, that is the best joke. Okay. So how is it different to a struct? Structs, yeah. So structs can have different data types in them, can't it? We had an int, a double, a char. You can have whatever you want in a struct, okay? As long as the data is somehow related, we plonk it together. There we go. It's a man-made variable. Done. But an array has to have, every single part of the array has to be exactly the same data types. Okay, so what it means is that if we want to be able to deal with this collection as a whole entity where we can access any variable in the collection and we can change any variable in the collection easily. So what are some examples, what are some examples that I can do? Let's say I want to record daily ice cream consumption for a week, and I swear I don't actually eat so much ice cream, but now I can't think of any other examples. So all of the examples from today are all about ice cream as well. I'm sorry. What about if I wanted to hold daily temperatures for a year? I'm not going to have 365 variables for each day of the year to then hold one little number. I would use an array for that because I can have an array with 365 elements in it, and so it's just one variable holding 365 ints because the temperatures are all the same data type. Amount of daily time that I spend walking my dogs, that's a lot as well. And you'll see a little bit about that. Can you think of any other examples of things that perhaps would be good to go into an array? I agree. I mean, after Messina, do you really need anything else? A bowling score. You can absolutely store a bowling score inside a student name. We haven't learnt about it, but you will be able to. Absolutely. Storing marks is a great one. Phone numbers, yes. Dice rolls, absolutely. WAMs, pixels, temperatures, exam marks, excellent examples. So absolutely, there is a lot that you can store. As long as it's all the same data type, you can store it in an array. Can you store structs in an array? That is an excellent question. And yes, you can. So you can have an array of structs, and on Tuesday I'm going to show you an array of structs and a problem with an array of structs, okay? So you can put anything into that array as long as each box of the array, so each element of the array is the same data type. And structs are just a data type, so that means you can have an array of structs. Absolutely. Okay, so let's have a look what it looks like visually. So if we group data type as a collection, we can access them as a group. We can loop through and access each individual element of that collection. Okay, let's say I create an array, okay, and that array has 7 integers in it. What it looks like in memory, I'm sorry, again, back to my obsession, it's ice cream and memory and dogs. I'm not really sure in what order, but the way it looks in memory is that when you have an array, every single element of that array is stored consecutively in memory. So if I have an array that holds 7 integers, what it means is that it will be 7 positions of memory right next to each other, each one holding 1 int. Okay, so they're going to be right next to right next to each other. So that means I can access them. As long as I know the address of my first one, I can access any of the other ones because I know where they are. They're right next to each other. Now, I can access the elements of an array by referring to their index. So when I have an array, my array has indexing in it, okay? What that means is that I'm able to say, I want, if I have 7 integers, I want, the 3rd one, the 4th one, the 5th one. But here is the catch, and here's why computer scientists often start counting at 0, is because the indexing of an array starts counting at 0. So if I have 7 integers in my array, it's actually the indexing is only going to go up to 6 because I start counting at 0. So the first element of an array is always stored at index 0. Okay, and we'll see a very common error is trying to access an array past. So accessing, if it holds 7 integers, trying to access something at the 7th index where there's nothing there, right? Because it's finished. And don't worry, we will practice all of this. Okay, so let's say, here we go, my first ice cream example before we take a break. Let me just go to the Slido. Okay, everything's going okay, excellent. Okay, so let's say I'm tracking my ice cream consumption over a week, and let's say I'm doing it without arrays, okay? So I'm going to have an int Monday, 2 scoops, in Tuesday, 3 scoops, in Wednesday, 3 scoops, in Thursday, you can tell it's getting the end of the week, 5 scoops, in Friday, after this lecture, 7 scoops, in Saturday, 1 scoop, in Sunday, 3 scoops. Okay, so this is quite hectic. That is a lot of variables to keep a track of, okay? So, not really a very efficient way to solve a problem. Okay, any day with 3 or more scoops is too much. What that means I'll have to do is I'll have to compare the Monday. Is it greater or equals to 3? Oh, then I have to print out too much ice cream. Then I have to compare the Tuesday. Then I have to compare the Wednesday. Then I have to compare the Thursday. Then I have to compare the Friday, the Saturday, the Sunday. So it's going to be like a lot of lines of code that are not particularly useful, not particularly efficient. This doesn't seem like a great solution, right? It doesn't seem like this is what we want to do. Okay, so, and that's for 1 week. I mean, it's doable, but it's not pretty, but it's doable, okay? So then what if I'm tracking this over a month or over a year? Does that mean I'll need 30 variables? Does that mean I'll need 365 variables? What if it's a leap year? My goodness, 366 variables? It's crazy. You're going to get completely lost. It's not going to be very good style, and certainly it's not going to be a very good way to do things. So this is where you would use an array. Okay, so let's talk about some syntax, and then we will take a break, and then we'll do it in code so you can see how to actually apply it. Okay, syntax of an array, okay, is number 1, how to declare an array. To declare an array, you say what type that array is storing. And remember, every element of the array is going to have the same data type. So I'm going to say, what is the type that is stored in my array? The name of my array, so in this case, ice cream consumption. And then you'll see I'm going to open a square bracket and close a square bracket. And inside, I'm going to have the number of items in that array. Okay, so there's 7 elements in the array, 7 boxes. But the indexing is going to go from 0 to 6 because the indexing starts at 0. So however many items there are in your array, your index will finish 1 less than that, okay, because it starts at 0. Okay, if I do this, I can't really then initialize an array in this way that I'm about to show you. What I can do is I can declare and initialize the array straight up, okay? So the way to do that is I will declare the array, which is this first bit here, and then to initialize some numbers in there to start with, I'll open a curly bracket and then write 7 numbers in here separated by commas, and then as per usual finish it in a semicolon. Okay, and that's basically how we initialize the array as well. So what that would look like, for example, if I had something like this. So I've initialized, declared and initialized to this line here. I've got an array of type ints. The array is called ice cream consumption. There's 7 elements in the array, and these are all the things I would like stored in there. Visually, it would look like 7 boxes put together. The indexing starts at 0, finishes at 6, and inside the first one is 3, inside the second one is 2, 1, 2, 1, 3, and 5. So you've got all sorts of wonderful things holding 7 integers, and the indexing starts at 0, which is pretty important. Okay, then to access any element of that array, I would call it out by saying which index that I want. So for example, if I want to do the third item in this list, I would want index 2. So this is the third item located at index 2. You will put the index inside square brackets, and that will give you the third element in that array. So if you try and access something at index 7, then what's going to happen is you're going to get a compiler error, and you're not going to be able to do much with it, but I'll simulate that error so you see what it looks like, because it's going to be a common one, right? You're going to get that error a lot. Don't be scared of it, because actually when you see it, it's really easy to fix. It just means that somewhere you've tried to access an array past the point of no return. All right, so I think now is a good time to take a little break, and then we're going to go and we're going to do a little bit of coding as well. Okay, let's do it. Break time. 5 minutes break time. Hi everyone. I hope you're enjoying your first forays into search algorithms. So this like riddle, this puzzle, it actually used to be, sometimes they'll ask things like this on tech interviews. And this one did used to be a question in tech interviews because it's like a search algorithm, right? So where are you going to find what you're going to do in the least amount of things? There is a number of different ways to solve it. I'm going to leave you, and if you're interested, I will put an answer on the forum, a detailed answer. But the least number of drops in this case could be 14. So anyway, okay, I will, but there's a whole bunch. You can use the binary search. I saw a few of you say that, but there's other ways to do it as well, not just a whole bunch of different searches that you can do to do it. Okay, back to arrays. All right, let's try declaring and using an array. How about that? Oh, my computer's even gone to sleep. Okay, here we go. I'm going to clear this so that we've got a clean slate, and I'm going to make it smaller so you can see code next to this so that you can see what each thing is doing. Okay, so the first thing I wanted to do, and then I might get Tom to pop the Slido thing in again just so that you've got it for the next lot of time. And because what I wanted to do is we're going to play around with an array. Okay, and then we're going to play around with two arrays. The world's your oyster. The world is your oyster. Okay, let's do it. So let's track ice cream consumption for a week. This is what I mean. I'm so sorry. I'm stuck on this one example. For next week, it's going to be a different example. It's just going to be, I'm going to do one, maybe me wandering, looking for ice cream around a map. Again, the world's, no, not my oyster, clearly just ice cream. Okay, so let's have a look. So the first thing we want to do is we want to declare an array. Okay, if I'm declaring an array, okay, we did it. I will specify what type is going to be stored in my array. So it's of type int. Then I need a the name of the array. So let's call it ice cream. Then square brackets. That will say that it is an array, okay? And inside my square brackets, I will put down how many elements I want in that array. Okay, so let's say I want 7. Fantastic. Okay, now, I cannot do something like, let's say I want to scan into this array, okay? I can't. Do I have an ice cream machine at home? You will not be surprised to find out that I do indeed have an ice cream machine at home. My ice cream is not as good as the one that you get from Messina, but I try. Okay, so if I want to scan in or if I want to print an array, I can't just do, even if okay, so let's say that's declaring an array. Now, if I declare and initialize, so I'm going to comment this line out, okay, just to give you an example. So that's how I declare it. If I want to declare and initialize, again, type of the array, name of the array, struggling, number of items, okay, and then I'm going to say to initialize curly bracket, and I'm just making up numbers now. 3, 4, 5, 6, one more number. Here we go, close and close. Okay, the reason I wanted to do that is to show you that if I want to print something out, okay, I want to print out I had okay, I can't just say, all right, great, could you just print out for me ice cream? Done. I can't actually do that, okay, because what happens is inside this array there are 7 numbers, okay, 7 numbers. So when I say to my printf, print out %d, I'm saying there's going to be only one number, okay? But in fact, in my array, I have 7 numbers. So what I can print out here is just one number. So I need to give it an index, okay? So not possible, okay? The same thing, I can't scan F into an array, just like here's some numbers, scan in. I have to do it one by one. So if I need to do however many things I need to do, this is where you're going to absolutely go to town with a while loop. because to scan through an array, to print out an array, to get into an array, to access many elements of an array, you have to do it one by one, or you have to do it in a while loop if you're going to, put them in one by one as well in there. So let's now do, what I'm going to do is we're going to actually just have an array, and we're going to initialize it by scanning some values into the array. Okay, so what I want to be doing is I want to ask the user, okay, how many scoops did you have today? And then I'm going to say scanf into something. Okay, and then I'm going to ask them, how many scoops did you have today? And then scanf into the next index. Now I could do it one by one, which means I would have 7 times 2, 14 lines of code. Or I can use a while loop and just change the index of the array each time. Okay, so should we do that? Let's try that. Okay, so whenever you're playing with your arrays, you're going to have something in here. Yeah, this thing here is called an index. Okay, this is the only time when in style you're okay to have a variable name that's going to be just one letter. Okay, this one is socially acceptable, int I. Okay, I is like an index, or and so you can use that as your variable to access whatever index it is that you need inside the array. Okay, I'm going to start counting it at 0. Okay, so I'm going to initialize it to 0. Okay, so the index is going to be equal to 0, which means that I'm ready to go into ready to access ice cream at index 0. So the very first element of the array. Okay. Okay. So now let's do a while loop. While I is less than 7. Okay. Now the reason it's not less than or equal to is because we start counting at 0. So that means at 6 we will have a full week. Now this 7 is not looking very pretty. I don't like this 7 because it's not changing, is it? I've just got 1 week. So what I could do is I could hash define it. Okay, so let's hash define this week. So I'll define a constant called week, and I'm going to say it's 7. That means I can also use it in here instead of that 7. Okay, and that means I can use it in here as well instead of that 7. Okay. So now I have a while loop. Okay, my index is 0 at this point in time. So I'm going to print out a statement asking the user, how many scoops of ice cream did you have today? Oh my God. Here we go. Okay. And then I'm going to scan in their what they're going to input in. So it's going to be a %d because it's an int that I'm scanning in. Okay, and now I have to give it the place where I'm going to scan it into. So don't forget your ampersand, and then I want to put it inside array, and I have to give it an index. Okay, my index is counting over here, which means that I'm going to scan it into index I. Okay, and then of course I have to increase my I, so I'm going to increase my counter by 1, which means that my counter is going to go up by 1 as well now. Okay, excellent. So now I have this lovely situation where I've been able to scan into my loop. Not my loop, I've been looping to scan into my array. Okay, definitely don't scan anything into a loop. That doesn't even make sense. Okay, so if we're to go through this while loop quickly, just to explain to you what's going on, okay, what's going to happen is over here at this first point, I've got I is equal to 0. So the first thing it's checking is 0 less than 7. Yes, it is. Okay, great. So I'm going to go inside the while loop and I'm going to ask, how many scoops of ice cream do you have today? We're going to scan it in. At this point, I'm going to put it inside. So at this point, I'm going to put it inside ice cream at index 0. Yeah. And then I'm going to increase I. So then I is equal to 1. I'm going to go back to the beginning of the while loop. Is 1 less than 7? Yes, it is. So I'm going to go back in here and now I'm going to scan into index 1. And then I is going to be equal to 2. And so on and so forth until I get to 7. Okay. So it's just going to go through that array and it's going to able to scan into every index one by one. Okay, excellent. Let's have a look. Okay, so now every time I do this every time. Here we go. Okay, so now we're ready to go on to the next thing. Okay, what do we want to do? I think now we want to print out what do we want to do? What would you like to do? Should we print out all the different days? Or should we... Yeah, let's print out all the different days. Okay, what should I do again to print out? What should I do to print them out one by one? And then we're going to make it a function, I think, yes. What should we do again? Can I just printf the whole array? Oh, someone's asked something so good. What if the size of the array is not known? My goodness. That is a very, 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 very good question. Okay, and that is one of the downfalls of using an array in C sometimes, is that I have to give it a size when I declare it, a maximum size, okay? So let's say I don't know how many things I need, and I'm going to say give it 1,000 ints, okay? And then I only put 3 items into it. What that means is I've just wasted 997 times 4 bytes of space, okay? And that is one of the downfalls of ints. So you have to give it a maximum value, because when an array is created, because each box of that array sits next to each other, they have to be consecutively located in memory. You have to know how big it is when you're creating the memory space for it. So that means that you will most usually overestimate. And then the only other way there is a way to give more memory, but you'll be able to give only memory based on that maximum size of array. You can double it or triple it or whatever it is, okay? And that's going to be one of the reasons we use a different data structure. Okay, so there we go. So that was a really great question. Total number of ice cream eaten is an excellent one, yeah. Okay, I haven't done return 0, that's true as well. Okay, let's print them out. Okay. All right. I'm going to print them out. So I'm going to go do a while loop again. Okay. So I'm going to do something. I'm just going to 0 the I again. Okay. And then I'm going to say it again. Whilst I is less than week. Oh, I'm going to print out. I'll do this before I forget, before I create an infinite loop, and I'll print out on day something, because I saw the last question, so I'm gonna play with the question that Tom just said I'll answer. Do I have to start with 0 for the count? Let me show you. Okay. Okay. On day %d, you had %d scoops of ice cream. Excellent. I forgot to put in what the things are. Okay, so on day D, so that's my index. And then how many scoops of ice cream is whatever is stored inside my array ice cream at index I. Yeah? Everyone happy with that for now? Okay, great. Let's run it. Let's see what it does. Okay, let's do it. Okay, let's DCC ice cream.co ice cream. Ice cream, you scream, we all scream for ice cream. I'm going hysterical. It's a Friday afternoon. Okay, how many scoops of ice cream did you have today? 1, 2, 3, 4, 5, 6. Is that... Oh no, it's going to go one more, of course, because it's 7 days of the week. Okay, on day 0, okay, we are having ice cream again if you've just joined us. A lot of ice cream. I feel like last lecture, I wish we were in person. I would have just ice creams for all. Damn it. Okay, on day 0, you had 1 scoop of ice cream. On day 1, you had 2 scoops of ice cream. On day 2, 3, 4, 5, 6. Okay, this is so weird, right? Because there is no day 0 unless we've started counting days differently. So I really want to start counting this at 1, don't I? Right? It's not, otherwise it's not very nice. Okay, so if I start counting my index at 1, okay, it's going to give me on day 1 is going to be the first thing, and then I'm going to keep going. So let's see what that does. Okay, and it's going to give me something that's not going to be very nice, but I think is an important thing for you to see. Okay, 1, 2, 3, 4, 5, 6, 7. What's just happened? How has it worked? 1, 2, 3, 4, 5. Aha, that's how it worked. 1, 2, 3, 4, 5, 6. Okay, I know how it worked. Yeah, okay. It should have thrown me to the dogs. What a disaster. Okay. So if I is equal to 1, what it's done is it's just started counting at I is equal to 1. Okay. Yeah, that's right. You need to do is less than or equal to do 7 days worth. Because if you see here, I have 1, 2, 3, 4, 5, 6. So I've only accounted for 6 days. So let's do, because I started counting at 1, I'm going to have to go up to and including 7. And now it's going to, I didn't mean to do that. And now it's not going to like me very much. Okay, clear that, compile it. Okay, so, oh, it really doesn't like me. It's just gone to, it's gone. It's gone. It hates me. It hates me. Okay. So what I was trying to show you, yes, is that it's going to have on day 7, okay, when it's equal to 7, when I is equal to 7, what's going to happen is that over here, I is equal to 7, great. But over here, when index is equal to 7, it's not going to like it very much at all, okay? Because it's not, when you go into index 7, there is no index 7. The array doesn't extend past that. So either I do I minus 1 over here, or I do I plus 1 over here and start counting at 0. So the best thing that we can do is start counting at 0, but then your day perhaps would be I plus 1 each time, and then your index can stay the same. So there is a number of different ways that you can solve this problem, but, you know, it's up to you how you do it with what makes the most sense. Now something has, I've got something that's just not working. Hold up, wait a minute. What did I change? Wait for it. I love coding so much. Where am I? 29, printf, you had to do, we had here, yeah, this yeah, I've gone back to 0. That should be just a less than symbol. Good. Oh my god, this team debug is amazing. You see my weird face just squinting at the, here we go, squinting at the screen trying to find the error. Okay, excellent. Good debugging, everyone. Love it. Brings a tear to my eye. Everyone's just... All right, and now it's doing perfectly. So now it's saying starting counting on day 1, but over here it's still giving me the right amount of scoops. It's not exiting an array. So it's doing all sorts of amazing things, okay? So you can't have a 7th index in here. Anytime you'll have a 7th index, it means you're outside in just a void of memory. You don't know there's nothing there. There's no array there. There's no int there. Who knows what's there, right? But not what you want to be there. Okay, fantastic. What about if I wanted to find the total number of ice cream I've eaten that week? Okay, and then we're going to maybe break it up into functions. Why not? Let's live a little. Okay, how about we do a total of the ice cream? Oh, I forgot to save the file, of course, always. Okay, total of the ice cream. There's 2 ways to do it. I could go through it again, another while loop. Actually, after you finish assignment 1, you're going to be the master of the while loop, okay? This is going to be your jam, just while I less than blah. while I plus plus. So you're going to get very familiar with this pattern of having a while and the index increase, decrease, whatever is happening. So I don't know if I should apologize now or later. Either way, I'm sorry. Okay, so we can do a few things, okay? We can either do another while loop. We can do that. Or we can just add them along as we go, okay? Which is, saving us some lines of code. So how about we do it as we go? So I'm going to say int total ice cream. Oh, that's not a great name. Okay, total ice cream. Okay, and then here I'm going to scan it in. And after I scan it in, I'm going to add it in. Okay, can you tell me what's going to be wrong here? Something is going to be so wrong. So if I do this and then I say, okay, I want to do total ice cream plus whatever I just stored inside my index I. Okay, what's going to be wrong? Yes, oh my gosh, amazing. Yes, I did not initialize my variable to start with, which means that the first time it's going to try and enter it here, it's going to throw me an error and it's going to complain at me very, very much. Okay, so now I've got that, and let's finish by seeing if our total has worked. So I'm going to print out the total ice cream. Oh, now that's not a variable name. I can do like this. The total ice cream scoops for the week. %D, new line, and what's the variable called? Total ice cream. Okay, excellent. Let's save it. Let's clear the screen. Let's compile it. Yes, compiled okay, and then let's run it. Okay, so it's all working, and then the total ice cream scoops for the week was 28 scoops. Just a nice, easy week, easing into the, term 1. Yeah, so then it's all working, very nicely. Is there a way to print out Monday, Tuesdays, day 1, day 2 when using the while loop? Indeed. So exactly the same as we've done it here, we can do it over here. So for example, how many scoops off the week? So how many scoops did you have? And instead of today, we can say on day %D instead. And then use the same trick that we used before. So just have your I plus 1 instead of just I. Because I starts at 0 and you want to have it as day 1 as opposed to day 0. So if you save that and let's run it again, compile and run. And then, so now it's saying day 1, day 2, day 3, day 4, day 5, day 6, day 7. And I don't know, maybe it looks a bit prettier. Yeah. All right. How's that? How's everyone feeling about these sort of the basics of arrays? How's everyone feeling? What about negative amounts of ice cream? Well, I haven't protected from that. So you could put in a negative number. Absolutely. Because I haven't got any if statements that's saying you can't have a negative number. I've just realized my head is also in front of the terminal. So that's not really ideal. I'm sorry. There we go. Oh, great question. Do we need to use all the slots within an array? No, you don't. You can have half an array that's empty. And this is what I mean. You have to give a size of an array, and you will usually give a bigger size than what you need if you're just putting things in and you're not sure how many things are going to go in there. So you're going to have wasted space. So you can definitely have empty spots at the back or at the front. But mostly at the back, because usually you start filling them up at 0. That's what makes sense logically. Okay, yeah, I feel like having ice cream now too. Okay, everyone's doing great, fantastic. Oh my gosh, should we go a bit harder? This is fantastic. I mean, how many people have voted? Great. Or have you only got one? You've only got one. Oh no. Okay. No, people are starting to drop off. Still okay? Still the same? All right. Let's do a question. Let's do a few other things. Okay. So let's say we have this situation, and what we have is, let's say, I don't know, let's say Tom's coming for ice cream with me. Okay, and he's going to have ice cream during that week as well. Why, I don't know. But anyway, he's here. That's the story. Okay, so I'm going to want to have two arrays. One array is going to keep track of my ice cream. One array is going to keep track of Tom's ice cream. Should we start a new one, or should we keep going in this file? How do we feel? Thank you, Tom. New one? Let's go new one. Let's go from scratch again. I like it. All right. It's called ice cream total. I feel like we need a different... If anyone wants to suggest a new context, let's do it. Okay? Please change me from ice cream based questions. I feel like I'm stuck in ice cream land now. I would like to change. Burgers. Dice rolls. I wanted to avoid dice rolls. We can do dice rolls if you want. Egg count. I like an egg count. Why not? Someone say KFC. Chocolate. Cake. How many kilometers I ran in a day? That'd just be 0 every single day. Bubble tea. Oh, you know, I've never had a bubble tea. I'm just going to put it out there. Ever. Okay? Ever. I've never had a bubble tea. So that would also be 0. Yeah, I know. I know. It's so weird, right? Yeah, I really do. I'm prepping myself. I need to have it. I know. Oh, don't cancel me. It's in the making. Look, someone's asking what's a bubble tea. Okay, so let's do... I mean, a few people said chocolate. I don't like chocolate. I know this. I'm really going to be cancelled. No chocolate. Someone said burgers. I do like burgers. Someone said moving average filter. Days ideal bubble tea. That could be fun. Okay, there are like 30 stores near UNSW. I know, but it's been raining for 2 weeks, so I'm literally just going downstairs to the coffee shop. Okay, so many. Let's do number of bugs. Okay, let's do number of bugs. I like that. Okay, I'm going to change the question. Okay, let's do okay, Tammy, you're coming into this question as well. I feel like it would be a little bit controversial for me to write a better piece of code. It's too late, I've said it. All right, let's do it. Oh, someone said, what happens if you submitted your last assessment 14 seconds late in the last assessment? I would be an absolute crazy person, just with some sort of very mean vendetta to hold against a student if I penalize them for 14 seconds late. So that's what happens. You do not get penalized for 14 seconds. Okay. Yeah, you definitely don't lose 3%. It's 14 seconds. Don't worry. Okay, let's see who's got more bugs. I feel like it's going to be like a game. Who's got more bugs? And then people have to like clap it out. This Friday's descending into chaos. Okay, here we go. Okay, let's do it. Let's do it. Got to catch them all like Pokemon. Oh, my kid's obsessed with Pokemon Go right now. Not that many people are anymore because people have moved on with life. But I'm back at that stage. Okay, solution steps. What should we do? What should we do? Okay, I'm going to keep track of their, so I want to keep track, okay, Tom's bugs. And I want to keep track of Tammy's bugs. This is the weirdest question ever. Okay, let's do it. Okay, so first of all, I'm going to keep track of their bugs. So, and they're counting them. I assume it's going to be integers when they're counting bugs, not doubles. So let's do declaring Tom's and Tammy's arrays. Okay, declare Tom bugs. And we're going to store it for a week. So I'm going to use 7s. We can change them to a hash define as well. Okay, and then I'm going to use a Tammy bugs as well. Oh, if anyone looks at this question afterwards. Oh, well. Okay, we've now got a Tammy bug and a Tom bug. Okay, so now let's load them up, okay? And what we can do is we can load them up together, kind of thing. Okay, so what I'm going to do is I'm going to declare an index, okay? And I'm going to set it at 0. So you're going to be very fond of this kind of pattern where int I is equal to 0, then you open your while loop. Because what that will do is you will always start indexing at 0, and then you will always increment your index as well. Okay, so what's going to happen is you're going to have a comparison here. So is the index less than a week, so less than that 7? Whilst that is happening, I'm going to do something, and then I'm going to increase that I. So whilst the index is less than 7, I'm going to print f. And I'm going to say, how many bugs did you find today, Tom? Tom's saying 6 bugs today. Okay, he's had that's not a bad day. Okay. Yeah, 6 is pretty good then. And then I'm going to scan it into, so I'm going to scan a %d into his array. So Tom bugs at index I. Okay, great. Now my index is still 0, so in the same place I can actually print out and ask Tammy how many bugs did she find. How many bugs did you find, Tammy? And then I'm going to scan it into, so I'm going to do a %d, and I'm going to scan it into the Tammy bugs array, still at the same index I. Okay, so it's going to be quite nice, quite handy, and also we're saving a bit of code because we're only really doing just load it up once. So I really means index, and I is a perfectly all right variable. Oh my gosh, yes, someone. Oh, well done. I forgot the ampersand. You know how I always say, don't forget the ampersand. I forgot the ampersand. Okay, so then we've got the ampersand. So what we've got now is we filled out our things for 7 days. Fantastic. Okay, so now we want to know who's got more bugs. Who's got more bugs? Okay, so now actually we should have been adding these bugs up, shouldn't we? So we want, so we want a total Tom bugs and a total Tammy bugs. Okay, int total Tom bugs. And I'm going to initialize them to 0 as well. And I'm going to say a total Tammy bugs as well. And I'm going to initialize them to 0. Tammy, yours is giving a very long variable. Okay, so here what I'm going to do is after all of this, I'm also going to add them up. So I'm going to say total of Tom bugs is going to be equal to total of Tom bugs plus whatever we just scanned in. So Tom bugs at index I. And then I'm going to say the same for Tammy. So total Tammy bugs is going to be equal to the total of Tammy bugs plus whatever we just scanned in. So whatever went into that array at index I. Oh, Tammy's changing her name to Tam. Oh, but now I have to change so much, Tammy. It's not worth it. I'm just going to keep the long variable name. Okay. So excellent. So what we have is this lovely situation here where we've now scanned things in and we've got two totals. So what do we do now when we want to find out who's got more bugs? Okay. So we want to find out who's got more bugs. I'm just going to keep saying that the whole night. Okay. Yep, if statements. Excellent. Oh, this is looking like the bowling assignment. It is. You're gonna get used to a lot of these patterns. Okay, definitely if statements. Okay, let's compare them out. Okay, if something, then something. Yeah. Okay. If total Tammy bugs, this is the epitome of my hell, having to do comparison, like having to do mathematical operators. Okay, if total Tammy bugs is less than total Tom bugs, okay, then, oh my God, both of your names start with T as well. This is, okay, that means who's won the game? Then Tom's won the game for more bugs, but we don't really want more bugs, so that's really not really. Someone's asked, but aren't both Tom bugs and Tammy bugs being stored in the same index? Aha, that is a very good question, and let me clear that up. They are in the same index, but in different arrays. So Tom's bugs are going into Tom bugs array. Okay, so even though the index is 0, 1, 2, 3, it's not the same as the one that are going into Tammy bugs array at index I. Even though the index is the same, the arrays are different that they're going into. Okay, so what we get is something that looks like this. We're going to get two arrays. This array is Tammy, and this array is Tom. Okay, and each one has 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now they each have the same index. Okay, so each of their indexes is the same. But when I ask Tom how many things how many bugs he's found, he says 6. It goes into his array. And when I ask Tammy how many she's found, it goes into her array. Okay, and then so on and so forth. So even though the index is at 0, the arrays that it's going into is different. They both really do look like Tom. I'm really sorry. This one can be Tammy. There we go. And then I'll ask them again. Okay, let's say I say, how many did you find today, Tom? He said, I found 3 today. So we're at index 1. It's going to go inside 3. And then I'll ask Tammy, how many did you find today, Tammy? And she's going to say, I found 1 today. So it's going to go into the same index, but it's going to go into the different array. So the index is the same, but the array is different. Okay? Okay. Okay, so if the total Tammy bugs is less than the total Tom bugs, that means Tammy's won the least bugs. Well, we're doing who's got more bugs, so that means Tom has more bugs. So in this case, Tom has more bugs than Tammy. And we can even give that difference out, can't we? We can even say what that difference is. So if we want to do the difference between will be total Tom bugs minus, I'm really regretting these variable choices, total Tammy bugs. Okay, here we go. So that's that one. Okay, so let's do another comparison now. Okay, so that's if that. What about else if total Tammy bugs is greater than total Tom bugs? Now in this case, Tammy has more bugs. Okay. And we can even say how many more she has total. Forgot to close. All right, excellent. And what's the only case left now? Yeah, oh, someone's got it. So there's only one other case left, okay? And that's going to be else. They're exactly the same. Someone said, is there an example for a char of arrays? Not yet. It's coming because an array of chars is a string. So it's coming. Don't worry. We're not going to do chars yet. Next week, we're going to do an array of structs, okay? And then we'll start talking about arrays of char. So don't worry. Okay. Just amazing. Okay. Else they have, Tom and Tammy have this. Oh, I forgot to do a printf. I'm just going straight out. Print it out for me. Know what I'm talking about. Tom and Tammy have the same amount of bugs. And that is the nicest thing that can happen, isn't it? Okay, let's see what happens. Should we see what runs, what doesn't? Is it going to run? Is it not going to run? Let's have a look. Okay. I don't know why I did that. I didn't need to do that. I was trying to DCC. Okay, DCC. The file is called ice cream total. That is not what we did, but that's okay. I'm going to call it bugs. Excellent. Okay, everything compiles. Let's run it. /bugs. Here we go. How many bugs did you find today, Tom? 6. Tammy, what about you? How many bugs did you find today, Tammy? Oh, there's a 10-second delay. I'm going to make up Tammy's number for now. What about you, Tom? Again, I'm going to make up your numbers because you take too long to answer. Okay, a lot of 88. Tammy, I thought you were going to... Oh, 99. I went a bit too strong. Tom, 101. Tammy, 5. Tom, 43. I don't know who I want to win here. Okay. And in the end, Tom has more bugs than Tammy by 16. Okay. So what we've done is we scanned those bugs, those numbers into each of their own separate arrays. Okay. And then we can play around with the arrays. Now we can also access the elements of the array. So far we've just scanned into it. But we can also say, well, we actually did it already, didn't we? When we accessed the index to print. Yeah, we did. Yeah, we did. But you can also print out different indexes. So to access the, yes, we did. Let me just double check. Did we print out here? Yes, we did. We accessed at index I. Okay, so this is an example of having, of working with really simple int arrays. Okay, they will get more complex. I'm really sorry. I don't want to go crazy pace. It will get harder. Not too much harder, but it will get harder. But I want you to wrap your head around just the simple array first. And then on Tuesday, we're going to go on and we're going to do an array of structs. Okay, so a few more things to hold on to as you kind of go through it. Okay. So, yep, we're going to actually, this is amazing. We're going to finish there for today because we've done our beautiful arrays. If you have any questions about arrays, pop them in the chat. Otherwise, feedback is appreciated, of course. If there's anything that you want me to do in the next 5 minutes, please do. How do you access a struct in an array? What a great question. And all will be revealed on Tuesday. Yeah, Jeffrey, kind of like that. Exactly like that, in fact. Yeah. And we will play with that a lot on Tuesday. What percentage of the lab tasks go towards our final mark? The problem sets are worth 15% towards your final mark. And we count the best 7 out of 8 for them. So if you're ever feeling down, you don't have to submit. Well, one of them won't count, the worst mark. Someone said 4 arrays, the maximum total number we can put is 7. No, I can do an array of 1,000 if I wanted to. To do that, I would just say here, okay, I'm going to go to 1,000 here. So I can do a maximum array of 1,000, but still ask only for 7 inputs, okay? So I can definitely have a whole bunch of things happening. Can you have an array as a constant? No, I'm not sure. Like a hash define, I'm not sure I understand. Good question, but I'm not sure. Can we have an additional tutorial session? Can you email cs1511 at CSC? Oh, someone's just done the boxes. Excellent. The problem sets of the lab are due Monday, 8 p.m. of the week after. So the week 3 problem set is due week 4, Monday, 8 p.m. Mike, we will not penalize you for that. In week 2, you forgot to put the date down in your header. You're not going to be penalized for that. No. This could be a good time to say we don't look at your style in your problem sets, only in your assignments. But please do nice style in your problem sets, because if I look at it manually to give you some marks, I want to be able to read it. So we can't use a struct array for assignment 0. I mean, you could if you wanted to, but I'm not. You don't really need to. And you can if you want to. You will not be penalized for it because we've taught arrays and we've taught structs. How can you access the lab marks from last week? You will see them on the submissions page. A random question about assignment 0. If you roll a spare in the first frame, does the total score count the first bowl of the spare as a bonus point for that spare? My God, my brain's exploding from that question. Hang on. If you roll a spare in the first frame, okay, so a spare is when you've rolled a total of 10. Does the total score count the first bowl of the spare? No, it's the next roll. So your bonus is the next roll after that spare. I think I've answered that question. Yeah. Okay. Are you allowed to use what we learned today for assignment 0? You can if you like. Yeah, because it's week 3. You can use anything you learned in week 3, but you don't have to. Okay. Ah, nice try, Mike. How about I do boxes.c? Yeah, that's nice try. I almost went for it. No. Spur, yeah. Band 6, we're not in, I think that's how they quantify school subjects, isn't it, in the ATAR? Yeah, we don't, no, that's not a uni thing. Will we have a struct revision on Tuesday's lesson? I am going to do a quick recap because I'm going to use a struct again and then I'm going to use it inside an array. So yeah, I'm going to do a little quick thing about it. Did the bowling calculator idea come up before you realized how confusing it really is to calculate the score? I tell you how it came up, okay? The other Tom went bowling with his friends. And on a Saturday night at 11 p.m., he sends a text message or a message to our chat that just has that photo with him scoring like 7 strikes, okay? And I'm like, what is this? This is just rude. Why would you? I still use bumpers when I bowl, okay? So I was like, this is just rude. And then he's like, oh, it'd be a great idea to calculate scores. And I'm like, it's so true, because calculating scores in bowling is really, really not that fun. So yeah, so there we go. So that's how it came up. So it really, that's a real photo in that's how the whole idea was born. And someone said, would a student aiming for a pass mark need to complete the 1 and 2 dot exercise in the labs in order to obtain the pass mark? You would have to be able to complete all the 1 dot exercises and some of the 2 dot exercises. You would at least be trying the 2 dot exercises. Are functions something we can talk about for the style video? They are, because you learnt them in week 3. 1,000 words comment, that's too many words. Can you get penalized for too much nesting for assignment 0? We're not going to look at your nesting in assignment 0, but we are in assignment 1. And that's because you're now going to learn about functions, and that's one way to remove some of that nesting, and probably the easiest way to remove some of the nesting. In the vector sum problem set this week involving structs, do we leave in the comments that were set inside? I'm not sure what that's asking. You can leave the comments that were there. Is the week 3 lab problem due the same day as assignment 0? It is indeed. Is there a syllabus for this course? There's a course outline. There's a course outline for every course, and you can find it from our website. So you're saying you don't want us to have fun. I absolutely want you to have fun. Coding is fun. Sometimes, though, you will spend many hours at the computer and you will get very, very frustrated. I strongly recommend that after a few hours, you get up and walk away and go and do something really, really fun to take your mind off whatever is sitting on the computer. Okay? Because sometimes it will be the most obvious bug and you will not be able to see it no matter how hard you look at the computer. Okay? And I know that sometimes people think, this is not for me, I can't do this, this is too hard. Please don't become despaired. All of us have felt like that at some stage and still do. I mean, if you've noticed how many times you've had a break in an auto test, that is us making some of these mistakes and having to debug them on the fly as well. So please don't, despair as well. And a lot of coding, I think a lot of it is about practice as well. So, try and practice as much as you can. Do those one-dot exercises for sure. Ask questions as well. Oh, the boxes problem, my goodness. Post on the forum. We will, there are some tips, I think, on the forum now for the boxes problem as well. You will be working on an assignment almost every week. There will be a break. I will give you a break in the after flexibility week, a small break without an assignment. Yay. Does passing the auto test in the labs generally mean you finished the question? It's a good indicator that you've got it, but passing all the auto tests doesn't mean that you'll pass all the auto markings as well. Okay, sometimes we will not put in every single case into the auto testing. Decimal spiral. If you watch Angela's Meet the Team video, she makes a joke about decimal spiral. I think it took her quite a few hours. I hate decimal spiral. So I really feel for all of you. I really, yeah. But it's meant to be a challenging questions. Can indentation and new lines be considered as two different areas for style? They're all kind of white space. So, yeah. Do we get an assignment straight after assignment? You'll have one day without an assignment between assignment 0 and assignment 1. I'm sorry. Yep. Yeah. But yeah. Because I want you to be able to have the assignment there, and I want to give you as much time as possible for you to be able to work on it consistently. And so when you have the assignment, it doesn't mean that you have to start it straight away, but what I want you to be able to do is to be able to read the assignment spec at least, and then take a little break from it as well, okay?
Sorry, could you say that again? Sorry, I'm having trouble hearing you.
Oh my gosh, my Siri's gone off. She does not like what I'm saying. Okay, would you recommend if we encounter a bug we restart? No, don't restart. I recommend that you walk away and take a break if you can't see what the bug is. No, Jackson, the assignment 1 is released all at once with the stages, and it's up to you to do the stages as you go along. Because by the end of week 4, you'll be able to do the whole of the assignment. So that's why it's going to be released all as one. Yeah, we're going to do a little bit more debugging. I know it's quite, yeah. Debugging is really important, and I guess the short term sometimes stretch me to be able to speak slowly and cover everything that needs to be covered, but I'm going to try and do more debugging as well. So I'll put more errors into my code so we can debug them as well. Yes, all our assignments are scaffolded into stages, so you will be able to know Perhaps you don't even want to attempt a 3-dot stage of the assignment, and that's completely okay. If you ever look at our performance marks, a lot of them are usually centered around stage 1 and stage 2, and you're able to pass assignments and even do a bit better if you've got good style if you just do stage 1 and stage 2. All right, well, it's time to finish up. Have a lovely Friday night, everyone. Have a wonderful weekend. I hope everyone stays dry. If you have any questions, post them on the forum or ask them in your classes. I will see you on Tuesday for another exciting adventure into arrays of structs. Yeah, there we go. All right, good luck finishing your assignment 0 and post any questions on the forum if you need to. Bye, everyone.